All right, so let's talk part two, ionic bonds versus covalent bonds. We're going to start learning how to represent covalent molecules and how to draw bonds and how to interpret bonds. So we need to know the difference between ionic and covalent. And if you look at these little cartoons here, this one over here says the name's bond, ionic bond, taken, not shared. So ionic bonds, they don't share. They either give up or take electrons. Covalent is different. Covalent shares. A covalent bond yells at an ionic bond. Didn't anyone ever teach you to share? That's the difference. Ionic bonds give up electrons or get electrons. So you can think ionic, letter I there, I give or I get. And you need both. Because if you want to give up electrons, you need somebody to take them. If you want to get electrons, you need somebody to give them to you. So these have to go together. And when you give up electrons, you form a positive charge. Because you have more positives than negatives because you gave up some negatives. And when you gain electrons, you form a negative nonmetal, an anion. So we need both of these players here to form an ionic bond. Those oppositely charged ions must be present in order for an ionic compound to form. Think I give, I get. So the metals always give away electrons and they become positively charged ions. Like here's magnesium giving away 2 valence electrons. That'll knock out its outermost energy level and make the energy level before it or closer to the nucleus the new outermost energy level, and that's full. And magnesium then becomes nice and happy, stable. But it also has a charge now. Nonmetals gain those electrons. Now chlorine has 7 valence electrons, so it only has room for 1. So one of these goes to that chlorine, but what do we do with the other one? Well, we find another chlorine. Nonmetals always become negative because they always take them, and when you work out the number of electrons that need to be given up and the number of electrons that can be accepted, then you can come up with the ratio that they bond on. Or you could cheat and just crisscross. Magnesium gives up 2, chlorine takes 1, put the charge there and the charge there. So it's Mg imaginary 1, Cl2. We're going to have one of these Mgs and 2 chlorines to bond with. And that's our ionic compound. The ionic compound forms when the oppositely charged ions stick together. All these positives and all these negatives are attracted to each other just like magnets. And we end up with this big crystalline structure that's alternating positive and negatives, and they all stick together. That's ionic. The charges determine what the formula is going to be. Covalent, these guys get creative. They're going to share electrons. They're going to cooperate for covalent. They're not going to give up electrons and take electrons. They're going to put their electrons together and share them in such a way that all atoms end up with an octet. No one is becoming positive. No one's becoming negative. We don't use ions. We don't use charges. That's ionic. It's in the name. Covalent, we're just going to share electrons. And those atoms are going to stay together because the nuclei of all the atoms are attracted to those shared electrons. So look at this example here. A little hydrogen only has 1 valence electron. It needs 2 because the first energy level can only hold 2, and that's all hydrogen needs. Nitrogen, meanwhile, has 5 valence electrons. It needs 8, so it wants to gain 3. So if you have hydrogen and nitrogen in a container, they're looking at each other saying, we all need electrons. Where are those metals who can give us electrons? And there are no metals, because ionic compounds have metals, but covalent don't. There's no metals giving up electrons in covalent bonds. So all we have are these nonmetals who have to cooperate, work together. So this little hydrogen says, I'm going to let you borrow my electron, and it's going to zip around you for part of the time. but you have to send it back with yours, and it can zip around me. So I'll have my 2 that I need, and you'll have my other electron for part of the time. When it's not zipping around me, it's zipping around you. So this guy is nice and happy, but nitrogen still needs more. So nitrogen looks at another hydrogen and says, what about you? And this little hydrogen says, well, I'll do the same thing. You can borrow my electron, and it'll zip around you for part of the time, but you got to send it back. So hydrogen will be stable once it shares 1 electron with nitrogen. And this little hydrogen will do the same thing. And that hydrogen will share these 2 electrons. So these electrons in the circles that I just added there are shared electrons. They go back and forth around the nitrogen and then around the hydrogen and then around the nitrogen and then around the hydrogen. And this happens so quickly that both atoms feel like they're stable, like they have the octet. And finally, if you look at the nitrogen, remember the nitrogen needed 8? Well, it's got 8. It just gets them part-time, but it's good enough. So this is the way we represent, or one of the ways we represent covalent bonds, the electrons being shared. They're in the electron cloud in the circle of both atoms. So we're going to use some language that you have to be familiar with. It's not hard, but you just have to remember what's what. Octet we know is 8. That's going to be the sum. That means when you add the sum of shared electrons, electrons that go back and forth between 2 atoms, and unshared electrons, electrons that do not travel back and forth. If we add them up, we should always come up with the octet. So atoms achieve an octet by having 8 electrons in their clouds. Some of these can be shared, and some can be unshared. We call them lone pairs. We'll get into that in a second. So everybody wants to pool electrons together, and between all the shared ones and the ones that they don't need to share, they should end up with 8, with the exception of little old hydrogen that only needs 2. This is hydrogen. It has 1. It just needs to add 1 more in here, and it will be happy because that first energy level can only hold 2. So let's talk about shared first. Shared pairs. Everything is in a pair here. Pair means 2. A single covalent bond represents 2 electrons that zip back and forth between 2 atoms. The 2 electrons that make up each bond spend their time in the electron cloud of both atoms. So when we're talking about a single bond, we're talking about a line that we're going to use to represent 2 shared electrons. So look at this image here. We've got a line between hydrogen and carbon. That line really represents 2 electrons. We can draw them in there if you like, 2 little dots. You just have to remember that every line is 2. It's a pair that goes back and forth, back and forth, back and forth. Now, if we have more than one bond, multiple bonds, well, then it just means we have multiple pairs. So if we have a double bond is just a line and then another line, 2 and another 2. That's a grand total of 4 shared electrons. So if we have element X and Y and we have a double bond between them, we know that they're going to share 4 electrons. 4 electrons are going to travel here, and then 4 electrons are going to travel there. And if we have a triple bond, we draw 3 lines, and then it's 2, 4, 6. It's grand total 6 electrons. So if we have X and Y and there's a triple bond, we know that they're going to share 6 electrons. 6 electrons are going to travel around the X, 6 electrons are going to travel around the Y. Back and forth, back and forth, back and forth till everyone's happy. So we're going to represent shared pairs of electrons with a line, a straight line. Now, unshared electrons. You can think of these as almost atoms being selfish. They hang on to their own electrons and they don't share them. They don't need to. We can also call these lone pairs. They're alone. They're not going back and forth between 2 atoms. So these electrons contribute to an atom's octet. Remember, we add up, we get the sum, but they're not shared. Since they're not shared, they're not represented with a line. We don't draw a line to represent these electrons because they don't travel back and forth. Instead, they're represented with a pair. Pair means 2 of dots, just like those Lewis dot structures. We draw 2 little dots. Little side note here, never, ever, ever, ever draw one single dot. If you're ever doing that, you're doing something wrong. Anytime you draw dots, they should always be in pairs. And again, pair means two. So if you add up the shared, which is our lines, all of our shared electrons, and all of the unshared electrons, which are the dots, you should end up with the octet. And unless it's hydrogen, it means 8. Hydrogen means 2. So if you add up all the shared and unshared, you should typically get 8. Hydrogen for us, hydrogen is really the only exception. So let's practice sharing electrons here. Here's chlorine. They share 2. Remember, this is 2. So this chlorine is going to share 2 electrons. This chlorine is sharing 2 electrons. They zip around the nitrogen and they come back and zip around the chlorine. So that's 2. This chlorine shares 2 electrons here. So they zip around the chlorine and they zip around the nitrogen. They go back and forth, back and forth. So we looked at the shared for the chlorines. Now let's look at the shared for the nitrogen. Here's nitrogen sharing 1, 2 with the chlorine, 3, 4 with that chlorine, 5, 6. It shares a total of 6 electrons. Now let's talk about unshared. Unshared are kind of like the selfish ones. These are the ones that don't get shared. They don't travel. So look at this top chlorine here. It's got 1, 2 of its own, 3, 4, 5, 6 unshared. What do we get when we add 2 plus 6? 8. This chlorine up here has 8 total electrons. It's got 6 that it doesn't share and 2 that it does share. Let's look at the chlorine on the right. This chlorine over here has 1, 2, 3, 4, 5, 6 unshared, plus the 2 that it shares. It's also got 8. So it's going to have a bond with the nitrogen, but also 6 of its own. Same thing with this chlorine. It's got 6 of its own plus the bond that it shares with nitrogen. That gives it 8. So right now, all of our chlorines are nice and happy. They all have an octet. What we want to look at now is the nitrogen. The nitrogen has 6 shared. 3 bonds times 2 each, that's 6, plus it has its 2 unshared. What's 6 plus 2? 8. And our little nitrogen has all 8. Anything that's in both circles represents shared. And then you add in the unshared. This is the deal. You want to get to 8. You want to get to your octet. The only exception is if it's hydrogen, there's 2. Let's look at hydrogen here. Hydrogen has a pair of shared electrons, 2 electrons. It has no dots around it. It has no unshared. 2 plus 0 is 2. That is good. That's what this little hydrogen needs to become stable. It doesn't need 8. 2 is good enough. We never, ever, ever put dots around hydrogen. This hydrogen over here, if you look at the bond, there's 2. Unshared, nothing. There's no dots around it. 2 plus 0 is 2. This little hydrogen is all set also. It's got its version of an octet. And finally, oxygen. Let's look at what oxygen's dealing with. Oxygen is going to share with hydrogens. It's got 1, 2, 3, 4 that it shares, plus 1, 2, 3, 4 of its own. 4 plus 4 is 8. Oxygen's not hydrogen, therefore it needs 8. Only hydrogen gets away with 2. You do the next 2 quickly. Hit pause, do the next 2, and then we'll come back and take a look at how you did. All right, hopefully this is what you did. Hydrogen has 1, 2, and no extra unshared, so it gets 2. This nitrogen has 2, 4, 6 shared, and 1, 2 unshared. 6 plus 2 is 8. And finally, carbon. Carbon has a whole bunch of bonds all around it. If you count up the bonds, there's a single bond here, that's 2, and a triple bond here, 2, 4, 6, that's 6. 2 plus 6 is 8. It's sharing 8 electrons. It has no dots around it. 0 unshared. 8 plus 0 is 8. They all have their octet. They just have to share or keep their own so that they add up to 8. Over here, we got a whole bunch of stuff going on. This oxygen has 2, 4 that it shares. It's also got 1, 2, 3, 4 of its own. It's got its 8. 2 in the double bond, and then 4 of its unshared. This oxygen, different story. 1, 2, 3, 4, 5, 6 of its own, plus the 2 in the bond. It also gets 8. Everybody needs to get 8. They just go about it differently. And then finally, sulfur. It is going to share 1, 2, 3, 4, 5, 6. And then it has 2 of its own. 6 plus 2 is 8. If you don't get 8, you did something wrong. Everybody but hydrogen should add up to 8. Hydrogen's the only one that gets 2.